Let me show you a simple DC brushless motor that's powered by an audio amplifier here in the background. That's a standby power of 1.4 watts. We'll use that later to calculate the power consumed. It consists of a permanent magnet for the rotor and basically two coils that are connected to the amp. One of the coils is a generator coil that, when placed in the motor, generates a voltage, as you can see on the scope here, as the motor spins. Let me switch over to the motor coil, and also you can see that the amplifier drives a current into the generator coil. Now when this is placed in the motor will spin, and it's just sort of a feedback loop between the input and output of the amplifier. This is just another variation of it, different kind of magnet, although the magnet's inside this casing here with some extra weight. Using smaller coils this time just to get a different effect. We'll place this carrier on top of that to hold the motor in place. Give it a bit of a spin. There's the motor coil now. Slowly we'll start accelerating it. Now this is another version of the same motor, although the size is scaled down quite a bit. Smaller coils, smaller rotor. But you'll see it'll run at a much higher frequency. As I put a load on the axis, you can see it slows down, draws a bit more power. It runs a lot faster than the other motor. So let me show you yet another version of the same motor technology. Slightly different rotor in the center, but essentially this is a permanent magnet. Now instead of two coils surrounding the rotor, there's actually four coils. You got one pair on this axis for one channel of the amplifier, and then another pair of coils on an axis 90 degrees from the first. That's connected to the both channels of the amplifier. And if I start it up, you can see it runs pretty fast. I'll put some resistance on the rotor. See, it'll slow down, seeing a lot more power. So here's another version of this motor technology. Multi-phase motor, however the rotors are in tandem in pairs of coils on both sides of each section. It might be a little hard to see as it spins because it's so quiet, but when you start it up you will hear it. That's running, consuming a bit more power, maybe 4 watts. You know, it has a little bit more torque because of the additional rotors and pairs of coils. So let me try to demonstrate another feature of this motor technology. I'm going to start with a simple single phase motor you saw in the first video. Let me start it up. And now I'm going to add in just additional rotors spinning in the opposite direction. And this being in proximity of the motorized rotor, it's going to continue moving that direction. Let me try to add in a third. The third one now is running, synchronized with the all three of them. And let me try to add in a fourth one. So now we've got all four of them spinning in a synchronized fashion, each of them in opposite rotations. But they can also be looped around. And now we form basically a four-way arrangement of all four rotors spinning in unison. One clockwise, counterclockwise, clockwise, counterclockwise. So let me show you another variation of how multiple motors can work together. This looks like a single axis, but in fact there's actually four unique axes that could be rearranged, being perpendicular to each other. So let me start it up. Here we have all four spinning synchronously. There we rotated two of them by 90 degrees, and the remaining two. Now we basically have all four running perpendicular to each other. Now let me show you another feature of this motor that's a little bit counterintuitive. I'll be moving the location of the motor coil, and let's see what happens to the frequency and the power. So first we'll start it up. You can see on the scope the input and output waveforms. The power is about 3 watts. And then as I start moving it further away, you'll see in the waveforms that it's speeding up. Also the power consumption is increased. A little bit further, it speeds up further, power's gone up, and then at some point it starts slowing down again. Although the power increases, you go yet further, power increases, and you slowly start the motor slowing down. To some point it just can't drive it anymore. In the opposite direction, pull it closer, it'll speed up, power starts going down. After some point, it slows back down again. I'll be exploring this with a different apparatus in the following video. So this is another version of the same DC motor. The red coil is the generator coil, and the green coil is the motor coil. And I'll first demonstrate how the position of the motor coil affects the speed. So as I move the motor coil in closer, you can see it actually slowing down, and I bring it further away, it speeds up. It sort of oscillates at this point. Now the other observation is now if I can move the generator coil perpendicular to that axis, so I push it away, it pulls the motor in. If I pull it towards me, it pushes it away. And now there's an interaction between the two coils. If I just let it go on its own, you can see the generator coil swinging towards you, which causes the motor to kind of go back and forth on the perpendicular axis. And there appears to be some interaction between the magnetic field in the green motor coil that pushes away the generator coil, and in turn the moving generator coil enforces the back and forth motion of the motor coil. I just thought that was an interesting observation. So here's another version of this motor. It will harness the circular motion of the motor coil. In this example, there are two generator coils located near a smaller tandem rotor on the top of the shaft, and a larger motor coil located near a larger rotor on the bottom of the shaft. The motor coil is on a two-pulley platform that allow it to pick up some circular motion, while the rotor spins independently. Let me start this up. So now you can see that the motor coil is picking up a circular force while the rotor spins independently. Of course, I can actually stop the motor coil. If I bring it close, you can see it slows down. I'm going to speed up further away it goes. And I'll just pick up the circular motion as it interacts. There's actually two magnetic fields, spinning magnetic field of the rotor and a spinning magnetic field that's generated in the motor coil based on the pickup here of the generator coil. I just thought that was an interesting feature of this motor as well. I'd like to show you this other aspect. Now this is just a rotor, no coils, not powered. Let me give it a bit of a kickstart. I'm not sure you can actually hear it. If you look at it, it's actually moving. In fact, it'll continue to move indefinitely. Very good bearings, but it's still... I left it there. It'll run for basically ever. But now I need to be honest and expose what's happening. Back here we have a spinning motor that's actually causing the other rotor to continue spinning just by proximity. Gotcha.